This lecture is to go over vectors. Vectors are used in the sciences, especially physics, to show force. Because forces like gravity have a strength, and they also have a direction. In the case of Earth's gravity, that's towards the center of the Earth. Vectors, then, have to have those same two components. So vectors, the strength of a vector is called the magnitude, and it's represented by the length of the vector. Vectors also have a direction, which is usually described as the angle it forms from the positive x-axis. So if I had my x and y axis, this is the positive x-axis here. So the angle it forms from the positive x-axis going counterclockwise is the angle that we're going to look for. So let's go ahead and look at two examples that we can find the magnitude and the distance. So our first over here is vector AB, because it goes from A to B. So I'm going to go ahead and use my distance formula to find the magnitude. So you can see I wrote my distance formula up here. So the magnitude is equal to, and I'm going to draw a really big square root symbol, x2, which is 1, minus x1, which is 5, that quantity squared, plus y2, which is 2, minus y1, which is 1, and that quantity squared. So we'll go ahead and do the math there. So it's going to be the square root of 1 minus 5 is going to be negative 4. Negative 4 squared is going to be positive 16, plus 2 minus 1 is 1. 1 squared is 1. So my magnitude is going to equal the square root of 17. And 17 is a prime number, so I can't take anything out of that to simplify the radical. Now to find my direction, again like we looked at in class, it's often easier to graph the points so that you can get an idea of which way your vector is pointing to make sure that you are doing your math correctly. So I'm going to go ahead and graph point A, 1, 2, 3, 4, 5, and up 1. So that's going to be my point A. And point B is 1, 2. 1, 1, 2. So this is my vector. It's not quite perfectly drawn. So even though my vector doesn't touch the x-axis, I'm going to draw a horizontal here and see that this is the angle I'm looking for. This angle right here. But whenever I'm finding the direction, I'm always going to end up using tangent. And I'm going to look at my diagram, see which angle I can find. So I can find this little angle here. I can't actually find the angle of direction, but I can find this angle, which shares a 180-degree line with the angle of direction. So if I look at this little angle right here, I can see that it's, if I use the tangent of that angle, this right here will be my opposite, and this will be my adjacent. So this is the change in y, and this is the change in x. So I'm going to call this angle theta. I'm going to use the Greek letter theta, because even though we haven't used that much yet, that actually ends up being used a lot when we're dealing with the direction of forces. So I'm going to say the tangent of theta equals, and then if you remember we use absolute value signs. In this case it's going to be the change in y, so y2 minus y1 over x2 minus x1. So I'll go ahead and fill that in. Tangent of theta equals, I already found my y2 minus y1 up here, and it was 1. And my x2 minus x1 was negative 4. Because I have my absolute value signs, it's going to end up being tan of theta equals 1/4. And now I have to use inverse tangent, so I'm going to multiply each sides by inverse tangent to get that theta all by itself. So I end up with theta equals the inverse tangent of 1/4. So let's go ahead and put that in our calculator and see what we get. So again, my calculator, things are entered differently than most of your calculators. So I do 1 divided by 4, and then inverse tangent equals 3.5 degrees. So that means theta equals 3.5 degrees. Now if I remember up here, I found theta, this little angle here, but my actual angle of direction is the other side of my vector. So my angle of direction is actually going to equal 180 degrees minus theta. So 180 minus 3.5 degrees equals 176.5 degrees. So that's my angle of direction. Let's go ahead and look at another example. This time I have a vector that starts at 0, 0. I'm going to go ahead and draw that now. So here's A. And actually I'm going to put my A in a slightly different spot because I see where my vector is going. So here's A at 0, 0, and B is going to be 4, -6. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So 4, -6. So this is the direction that my vector is going. That's B. So let's go ahead and find the magnitude. Again, we're using our distance formula for the magnitude. So magnitude equals the square root of, and let's go ahead and scroll back up so you can remember what that is. x2 minus x1 squared plus y2 minus y1 squared. So this one is kind of interesting because both of my y2 and my x2 are 0. So it kind of saves me a little bit of time. So this is just going to end up being 4 squared plus -6 squared. So it's going to equal the square root of 16 plus 36. It's going to equal the square root of 52. So go ahead and leave that like that. Let's go ahead and scroll down, and we're going to find our direction. So let's go ahead and look at our graph. So ultimately, the angle we're looking for is this whole big angle right here. But the angle that's going to be easiest for us to find is going to be this angle right here. So I'm going to call this my angle theta. And if I look, my angle of direction is going to be 360, that's a whole circle, minus theta. So we're almost going to 360, but we're just going to go back to just the amount of theta there. So let's go ahead and look at how we're going to use our trigonometric functions. So I'm going to go ahead and draw in the rest of my triangle here. So if this is theta, and I don't know my hypotenuse, but I know my y and my x, so my y is opposite of theta, my x is adjacent to theta, so that means tangent of theta is going to equal the change in y over the change in x. Oops, that's supposed to be an x, sorry about that. And we use the absolute value of that. So let's go ahead and fill in our numbers here. I'm going to scroll down a little bit. So tangent of theta equals, I already found my change in y, that was -6. My change in x was 4. So that ends up equaling, my negative drops out when I take the absolute value. I'm just going to go ahead and turn that into a decimal because I already know that 6/4 is 1/5. So tangent of theta is 1.5. I just said 6/4 is 1/5 is 1.5. I'm sorry. So tangent of theta is 1.5. I'll take the inverse tangent of both sides. So I get theta equals the inverse tangent of 1.5. I've lost my calculator. Here we go. So 1.5 inverse tangent gives me 56.3 degrees. So I'll go ahead and write equals 56.3 degrees. And if we remember from up here, we just found theta, so we need 360 degrees minus theta. So 360 degrees minus 56.3. Let's go ahead and do that in our calculator. I get 303.7. So my direction, I'm going to go ahead and write there, is 303.7 degrees. The next thing we need to do with vectors is look at vector addition. So the way that we've been doing vector addition is what's called the triangle method. It's where we put our vectors tail to head and we draw a new vector that's tail to head. So if you want to be really corny, you can sing a little song. The vectors always go tail to head, tail to head, tail to head. The vectors always go tail to head when we add or subtract them. So if you hate that song, then just pretend that didn't happen. So I'm going to redraw my vectors. Whoops. So here, let's see, magic pen. Wake up, magic pen. Here we go. Okay, so if this is vector A, this is vector B, so to subtract vector B, I take vector B in the opposite direction. But like I said, they always go tail to head, and now tail to head. So I'm going to draw the opposite direction of vector B, tail to head. And then I'm going to draw in my resultant, which is the answer vector, again, tail to head. Whoops, and that disappeared for some reason, tail to head. So this ends up being my answer. Let's do another one. We'll go ahead and start out with vector A. Whoops, that's a pretty crooked vector A, sorry about that. And we're adding vector Z, blah, blah, blah. We're adding vector Z, which means we put vector Z tail to head just like it is. So I'm just going to draw vector Z like it is. And then I go tail to head. And that's my answer. So that's our quick review of vectors.